Okay, so we're multiplying radicals today. The key here is, guys, if you want to multiply radicals, please look here. Guys, please. The key is here, guys, these numbers underneath here can be different as long as the k's are the same. What are those k's there? As long as it's a square root and a square root. As long as it's a cube root and a cube root. As long as it's a quad root and a quad root. Can you do a cube and a square root together? No, that's the main thing there. You cannot do those. They have to be the same roots. Okay? So let's do this now. They're really quite easy once you get the hang of them. Basically, you have a radical and a radical.
Pretty much just like multiplying fractions, where you can multiply one fraction and multiply the other.
Yeah, you do that. It's like distributive property in some way, right?
No, it's more like fractions, where you multiply the top and multiply the bottom.
Okay. Okay, so hang on. So let's do this. So it's negative 3 times 4. That's the numbers that are out the front. And then underneath the root symbol, what are we going to have? 2x times 6. Yeah? Not that bad. Okay, so what do we get? What's negative 3 times 4? Negative 12 root of 12x. Now, the only thing is, you're not done when you get these things. What do you always have to do with your radicals? Simplify them. You got to reduce them, right? Sometimes it's easier to reduce on the fly. Sometimes it's easier to reduce after you get the answer. So what we're looking for this one is factors of 12 that you can take the square root of. 4 and 3. Okay? So 4 times 3 times x. Okay? What's the square root of 4? 2. So when it comes outside, you still have to multiply by the negative 12. Negative 12 times 2 is root of 3x. Yeah? What do you think? Not bad? It's not that bad. Where did the what? Sorry? Because it's the square root of 4, right? If you want, hang on, if you're missing that step there, what I would recommend doing is don't jump to that last step, but do it this way. Negative 12 times, what's the square root of 4? 2, right? 3x. So then you get your negative 24 root of 3x. You see? Because all we did was take the square root of 4, so it's 2. Write that down if you have to, if you're going to miss that step. Okay. Now, this one here is slightly different. Instead of a radical and a radical, we have a radical, but we have two radicals within the bracket separated by a subtract sign. What's that called, that property? Distributive property. Guys, you treat it like you would remember binomials and stuff? You basically are doing that, right? You're distributing that 7 root of 3 to both those pieces in there. Okay? So let's do that. So we're taking 7 root of 3 and we're timesing it by 5 root of 5. Is that correct? Is that the first part we're doing? Okay, I'm just going to separate these two. And then we're going to take the negative 6 root of 3 times by 7 root of 3. I guess I should be consistent and do the 7 root of 3s at the same time, eh? Really doesn't matter when you're multiplying, right? I should try to be consistent. Like I should have done 5 root of 5 times 7 root of 3, and then those would have been the same.
Well, is that 7 square root of 3 bracket 5 square root of 5 minus 6 root of 3?
Well, look here. It's these first two, and these second two, and there's a negative in there, right? You subtract. You could put all of this second part in brackets if you're unsure of it.
So that's all in brackets? Like that's negative?
Yeah, this whole thing is basically the whole thing in brackets, right?
Okay.
If you want to get fancy with that, but
Can you say fancy?
you can stay fancy if you want. Okay, so let's do this. 5 times 7. 5 times 7. 35 root of 3 times 5? 15. Yeah? It's easy, that part, eh? Minus 6 times 7? 42 root of 9. Are you done? Should you simplify? Always. Now, is 15 going to break down, guys? No, it's 3 and 5 and 1 and 15. None of those are square roots. So that part alone itself, the 35 root of 15, that's as simplified as you can get. But we can do the next part here. What's the square root of 9? 3. Okay, so 35 root of 15 minus 126. Now, here's the cool thing. Well, I guess I should say cool thing. Here's one of the most common mistakes you guys will make. You'll get to this line here, and you will miss the obvious. What are you going to miss? You're going to miss the square root of 9. I guarantee some of you will leave it as square root of 9. You won't see that. Because you're so used to these wild and crazy radicals, you miss the common ones, right? Okay, next one. Uh-oh. What about this guy? Basic rules. You know this. 4-letter acronym. First, outside, inside, last. Can you use FOIL on this? Mm-hmm. Just FOIL. Let's do it. Now, what we're going to do to make this a little bit easier for you guys, when we write this out, we'll write out the full line here, right? You'll get faster at these as you go along. So the first one is going to be 8 root of 2 times 9 root of 5. So I'm just going to put that here. 8 root of 2 times 9 root of 5. That's the first one, right? Is that correct? That's the first? Okay. So let's do outside. So now we're going to do this. So what's the outside? 8 root of 2 times 6 root of 10. 8 root of 2 times 6 root of 10. I'm going to run out of room here, aren't I? Got to stop writing so large. We'll get to that. That's first outside. Now what do we got? Inside, right? What is that? Minus 5 times 9 root of 5. I can put brackets around the 5, but I really don't need to in this case because it's just simple. And the last one, what is it? That's not the last one, is it? Oh yeah, that's last. Negative 5 times 6 root of 10. It is quite long, but if you stood organized, is it really that difficult? No. Yep. Well, it's hard for you because you're not writing it down. Guys, you got to keep yourself organized, right? I do this all the time. I know what I'm doing, and do I still draw in the lines? I draw in the lines all the time. Okay, so let's do this part here. So we're doing this first multiplication. 8 times 9. 72 root of 10. That's easy. Okay. Plus 8 times 6. 48 root of 20. Well, that's not bad. Minus negative 5 times 9. 45 root of 5. Negative 5 times 6. 30 root of 10. You're done, right? You go for coffee, right?
Yeah.
No, you got to reduce it. Now, the key is you always try to simplify this, so you're looking for common radicals, right? Well, the 10s are nice. Can you reduce 10 at all? Root of 10, will it reduce? 1 and 10 and 2 and 5. Can you take the square root of any of those? Other than 1, obviously, but... Okay, so that doesn't work. What about that 20, though?
Yeah, 10.
4 and 5, right? Yep. So let's break this down. You want to combine our 10s right away, these two here? Okay. So what is 72 minus 30? 42 root of 10. Okay, so let's simplify this guy here. So this is going to be 48. We're going to break it down into what two factors? 4 and 5, right? Is that correct? Minus 45 root of 5. Right? You see where I got this original 42 from, though, right? The 72 minus the 30? Those are common radicals, right? Treat it like this. If I gave you 72x minus 30x, what do you end up with? 42x. Well, that's exactly what's written there, right? Just instead of the x, we have a root of 10. Okay, so 42 root of 10 plus, hey, what's the square root of 4? Times 2 is 96 root of 5 minus 45 root of 5. Do we have another common set of radicals here? Those ones there, right? So we can go 42 root of 10 plus, what's that, 45, and 9, what's that, 51? 51 root of 5. Are we done?
Yep.
Common mistake coming up. Now what do people do on this last line? Common mistake. Do they combine those? Do I see 93 root of 15 sometimes? Yeah, don't do that. Don't add all that stuff together. Guys, they have to be common radicals, which means they both have to be the same root, but in that case the base has to be the same. That's if you're adding or subtracting. Does that apply to multiplication? No, they only have to be the same root, right? Either cube roots or quad roots. These look complex, but they're really interesting, right? This is great stuff if you want to impress your friends at parties, right? Do one of these on a piece of paper, and they'll be so impressed with you.
Like write down the blue
Hey, let's do dividing radicals. Now,
it's the same thing, like...
it's the same thing. The big thing here, guys, look, A and B underneath the radical symbol can be different, but the only thing is they both have to be the same roots. So they both have to be the square roots, they both have to be the cube roots, right? That's the key thing. They have to be the same roots. If it doesn't work,
Oh, so they're going to get back.
no. They have to be the same roots. Okay, so let's do this first one. I have a whole bunch more of more complex dividing ones coming up, but I got to teach you rationalizing the denominator first. Okay, under the same roots, they're both cube roots, right? So what can we do? What's the front part? What's 4 divided by 2? 2 cube root of what's underneath the radical symbol? Hey, look. Now look, all we're saying up here is if they're separated, can you actually combine them? If it's the root of A divided by the root of B, yeah, you can put it all under one thing. So basically what's underneath there is you could do this, right?
Yeah.
Okay? Yeah, we are. We're getting to the next step. So 2 cube root of, what's 6 divided by 3? 2. I have a whole bunch more of these coming up, but before I get any further with division, I got to teach you about rationalizing the denominators.
Excuse the interruption. With those students going to C13 at the auditorium with Mrs. Butterfield at noon, please go to the cafeteria now for lunch. Thank you.
I could eat lunch here and then go. Okay. Now, we talked about this quite a while ago when we did unit circles. You remember under unit circle, we ended up with rationals or radicals on the bottom? Remember, and I said, in reality, we never do that. We never leave a radical on the bottom. We do something called rationalizing the denominator. So what you're doing is you're simplifying an expression that has a radical as a denominator. Okay? So what we're trying to do is get rid of the radical on the bottom. Can you have it on the top? By all means. You can have it on the top as many times as you want. The bottom one, though, has to be a nice number. Okay, so let's look at this here. What can I multiply the bottom by to get rid of the root of 3? No, you can't multiply by negative root of 3 because that would be like if you were adding or subtracting. We're talking about straight multiplication. To get rid of the root of 3, hang on. To get rid of the root of the 3. No, what would you times it by? No. So you run it times root of 3 by 2, that doesn't do it. That gives you 2 root of 3, that doesn't help. Times by 3, that gives you 3 root of 3, that doesn't help. No, 1 is root of 3 times 1 is still root of 3. We still have a radical every time we do that. No, multiply. We're talking about straight multiplication. You guys are overthinking this. What is the radical right there? Ignore the 2. What is the radical? Root of 3. If I times root of 3 by root of 3, what do I get? Which is 3. Does it get rid of the radical? Yes. Look, if I take root of 3 and I times it by root of 3, I end up with root of 9, which is 3. Did that get rid of the radical? Okay. So what I'm going to do is I'm going to times the bottom by root of 3. But What's our rule about math? What do you times the top by? Do you have to, if you multiply the bottom by root of 3, do you have to multiply the top by root of 3? Is that our basic rules of math? Okay. So what do we end up with on the bottom here? 2 times root of 9, right, which is 2 times 3, which is, what's on the bottom? 6, okay. I'm just doing the bottom now. I'll do the top in a sec. I'm just showing all the work. You don't normally need to show all that work. Okay, so what is 5 times root of 3? 5 root of 3. Does that change at all? Or is 5 root of 3 just 5 root of 3? Oh, 5 root of 3. 5 root of 3. Oh, okay. Kind of a waste to write all that in. Okay, so look here. 5 divided by 2 root of 3 is equivalent to 5 times root of 3 over 6. They're equivalent fractions, right? Just like 1/2 is equal to 2/4, right? They look slightly different, but they are exactly have the same number. And if you don't believe me, could you actually do it on your calculator and see? Get a decimal? I bet you they're the same. Okay, so if you want to rationalize the denominator, you multiply it by whatever the radical is. Okay? Now the problem is you're not always going to get ones that look like that. You're going to get some that are in the binomial form. Right? Is this a binomial? Is it separated by addition or subtraction? Was this one up here separated by addition or subtraction? No, it's just straight multiplication. Okay, so if we have something that's binomial, what we do is we do something called the conjugate. Conjugate's really easy. Super, super easy. Conjugate is two binomial factors whose product is the difference of squares. Do you guys remember the difference of squares? X minus 3 and x plus 3. They're exactly the same letters and numbers. The only difference is the sign in the middle, right? You remember that? Difference of squares? The two center terms cancel out. So treat it that way. You have a 4 and a root of 6. So what would the conjugate be? 4 and a root of 6, and the only thing would be, it'd be a positive. Oh, that's the conjugate. If you multiply these two things together, would the two center terms cancel out? Yes, they would. Then that's what we want, because that's where the radicals are. Oh, we have a 2 and a root of 3. This one's negative, so it's now a plus. That's the conjugate. No, we're not done yet. I'm leading you to the next step. Okay, we have a root of 5 and a 7, so it's a root of 5 and a 7, and the difference would, that's a positive, this would be negative. That's the conjugate. Okay, so now what I got for you is we're going to do 3 examples. These are all division. And what's going to happen is the last one is going to be with a conjugate. And the first 2 are just going to be with rationalizing the denominator. You'll see in a sec. Okay, here we go. Divide radicals, simplify each expression. Simply, yes, I can't spell. I'm a math teacher, I can't spell. You know that. So let's be simplify. Divide radicals, simply each expression. Is that better?
Yeah.
When they hear this later, that's going to make no sense to them, isn't it? Okay. Now first off, guys, can you divide these radicals? Are they the same radical? Are they both square roots? Yeah, they are. Okay. So these are separated. The first thing we can do is take them and put them all together, right? Underneath the radical symbol. That was one of the rules. Okay, so let's do that. So we end up with square root of 24x squared over 3x. Is that correct? It's all underneath the radical symbol. It's the same thing. The only difference is instead of 2 radicals, we have it under one big old radical. You can do that. Okay, what's 24 divided by 3? 8. What's x squared divided by x? X, right? We know our basic rules of powers, right? Same base, you're dividing, you subtract the exponents. Okay, 8x, is that in its simplest form?
Yeah.
Nope. It breaks down into 4, 2, and x. Is that correct? What's the square root of 4? So 2 root of 2x. Yeah? Easy so far?
Alright.
The problem is do you have to remember all those rules, like from grade 9 and grade 10 and now all these rules? You'll get better as you do them. How do you remember to what? Because you keep redoing it. And one of the things about math is, right, I mean, I could teach you a concept, I could tell you what the concept is, but until you actually put pencil to paper, right, and you do it over and over, it's all about, a lot of it's about repetition. And then it's like biology. How do you remember biology terms? You have to memorize them and you have to say them over and over again, right? It's the same with math. You just got to keep doing it over and over again. Okay, let's do this one. Okay. Now this one's interesting. Look at the terms. Are they both square roots? Yeah. But could you do 4 divided by 3? Now without being a really ugly number, right? What about 5 divided by 2? Now, really, okay. So this one is not really about doing the division. It's about rationalizing the denominator because we want to put it in simplest form. But the problem is there a radical in the denominator? Is there a radical in the denominator?
So couldn't you just say times square root of 2 and then...
So times the bottom by square root of 2? Okay, hang on. So what you're telling me is you're going to take this and you want to times the bottom by root of 2.
Yeah.
So what do I times the top by then? Right? Isn't that the rule? If I times the bottom by something, I got to times the top by something? Yeah, so it's basic definition of math, right? That hasn't changed. What?
Is this the right way to do it?
Yes, this is the right way to do it.
Okay, so I should write it down?
Yes. You're afraid that he was wrong or what?
Yeah.
I do that sometimes, don't I?
Yeah.
Okay. So let's do the bottom part here. So we end up with 3 root of 4.
I've got it. All right.
It has to be. But that's why we're going to get into the conjugate soon. Difference of squares. Now what's on the top? 4 root of 10n. Is that right? You do the 2 and the 5. In some ways, I think the multiplication and division is way easier than the addition and subtraction. That's my opinion, but... Okay, so let's reduce this a little further. So 4 root of 10n over top of, what's 3 times 2? 6. Okay. But you're not done. You can reduce this. Yes. Guys, look. Let me give you a basic example. What if I give you 4x over 6? It's going to be on the side here anyways. What do you do with 4x over 6? What can you reduce this to? 2x over 3. Can you do the same thing with that radical? Yeah, you treat that root of 10n like an x. You treat it like a variable. It's just sitting out there. You treat it like a variable. So 2 goes into the 6, 2 goes into the 4, you end up with what? 2 root of 10n over top of 3. Now, you see how the one on the right there is the same as this? Your basic rules of math don't change, even though they get more complex, right? The basic rules are still there. If you ever struggle with these on a test, go back to a basic example. What? Okay. Right? This is just extra here, right? This is an extra, right? Just so you know what we did there. Okay. Now, here comes the tough one. Next page. Now, you are going to find, guys, these questions, they now start to take a little bit more space.
Times square root of 5.
Which one?
This next
No, hang on. Now, look at that. Okay. So Justin asked, he said, well, this one you could just times it by the square root of 5, right? Well, don't write this down. Let's just check to see what this looks like. Square root of 5 plus 7, and we're going to times this thing by the root of 5, because that's what you said, right?
Yeah.
Now, what's the problem here? These two are going to cancel out. Those two are going to work, right? But what happens when you do this guy? You're going to get 7 root of 5. Well, you didn't get rid of the radical, did you? Okay, so that didn't work. Okay, that doesn't work. Good.
But I felt like you do what you just did. We do it on the other page.
Ah, this is different. Why is this one different? Don't look. It's got a binomial on the bottom, doesn't it? Yes, what's that called? The conjugate. We need to multiply the sucker by the conjugate. Okay, so what I would do is, if you're unsure about that, I would say, hey, the conjugate, I'm going to write it down up here, conjugate. What is the conjugate in this case? It's root of 5 and 7, but the only difference is instead of a plus, it's a minus. That's the conjugate. Because if we multiply those two binomials together, we're going to get rid of the center two terms. It's a perfect square. So it's a difference of squares. Let's actually try to speak the right language. Okay, so here we go. We're going to take this guy, and we're going to times it by what? Root of 5 minus 7. Now, if I times the bottom by root of 5 minus 7, what do I got to do to the top? Exact same thing. Okay? Okay? It's not as hard as you think, as long as you follow the rules. Even if you don't understand this, can you follow the rules? Yes. Okay, so let's do the top. Now, if you look at the top, this is like one of the first examples we did, distributive property, right? That 11 goes with both of those, doesn't it? Yeah, that's okay. So we're going to do the top. So this 11 goes with both of those terms there, distributive property. So what is 11 times root of 5? 11 root of 5. Ooh, that's tough. Right, it's just like what's 11 times x? Well, 11x, right? And what's 11 times negative 7? Negative 7 is 7. Okay, so that's the top. Well, that's not bad. I can handle that. Now, the bottom. Because you're multiplying by the conjugate, you're using FOIL, right? First, outside, inside, last. But what happens to the O and the I? What are they going to do? They're going to go away, right?
They die.
They die, yes, they die. Right, we know right away the O and the I are going to disappear, right? For instance, this little side one here, just don't write this down, but if I gave you x minus 3, x plus 3, right? If you wrote this all out, x squared minus 3x plus 3x minus 9, right? You know right away, when you're talking difference of squares, those two center terms disappear, don't they? So on a question like this, do you even have to do the two center terms? No! Don't waste your time. Go right to the F and the L. Okay, so we're going to do the F and the L. So the F is first, and the L is those two. Isn't that correct? Okay. Really quite easy. What's root of 5 times root of 5?
5.
5, or root of 25, or just plain old 5. Right, is that correct? Root of 5 times root of 5 is 5. What's root of 2 times root of 2? 2. What's root of 36 times root of 36? What's the cube root of 7 times the cube root of 7? 7. Guys, it doesn't matter. Okay. That was the top, so the bottom is 5. Now careful here. 7 times negative 7, negative 49. Oh, look, do we have any radicals on the bottom at all? Oh, isn't that what we wanted? We wanted to rationalize the denominator, right? We wanted to get rid of the radicals on the denominator, and we did that.
Ow.
They can be on the top. It doesn't matter. They can be on the top as long as they're not on the bottom.
I told you why you can't use the other way, like times this.
Because I showed you up the top there, it didn't work.
No, but like, can't you just times if I thought?
No. Yes. No. It's only if the radical is on the bottom, you rationalize the denominator. That's the only time you change it. So let's do the math here now. You just leave it there. Okay, so here we go. So we end up with 11 root of 5 minus 77 over top of 5 minus 49, negative 44. Okay. Oh, hang on. Yeah, you always try to simplify stuff, don't you? Now look here. You're looking for a common factor. What? You can do it by 11. Now, you have to realize it has to go 11 out of here, here, and here. Right? It has to go to all three because we're divided by that. So we can go, you can take, I would actually take not just only 11, I would take negative 11 out. I like positive numbers. It really won't make much difference. Take 11 out of all. Negative 11 out of all, yes. Okay. So we take negative 11 out of all. We end up with negative root of 5, is that correct? Plus 7 all over top of 4. Now, you could write that one way, or could you write it a different way? What's the other way? Or, what if you didn't like the negative at the front? 7 minus root of 5 over top of 4. Is either way correct? Yeah. Does it matter to me? No.
Don't we need to put negative 11 outside those?
No, we divide everything by negative 11. Right? You take divide negative 11 out of there, negative 11 out of there, negative 11 out of there. So we're not actually taking out, we're just reducing it, right? What do you think? Really, the only way to do these is to, right, get your pencil on your paper and do it. Now, you guys have 20 minutes left, and all Monday.
You're staying for lunch, right?
Yeah, I'll stay for lunch. All right, here's how to get at it. Hang on.